Consistency demystified, eventual versus strong. Make the right choice for your distributed system. How do distributed systems decide whether to prioritize speed or data accuracy? The answer lies in the battle between eventual consistency and strong consistency. In today's video, we'll explore the core concepts of eventual and strong consistency, real-world examples to showcase their strengths and trade-offs, and practical tips to decide which consistency model works best for your system. By the end, you'll have the clarity to choose the right consistency model for your architecture and ace your next system design interview. Let's dive in. In distributed systems, consistency determines how data remains uniform across all nodes after a write operation. It's a balancing act between ensuring data accuracy and maintaining high performance. The challenge? Balancing these trade-offs to suit your system's needs. Let's start with eventual consistency. This model allows temporary inconsistencies between nodes. Over time, all replicas converge to the same data state. Think of it like sending a group text. Some people get it instantly, others see it after a delay, but everyone eventually gets the message. This approach works great for systems where speed and availability are more important than immediate accuracy. Eventual consistency is all about patience, accuracy, but on its own timeline. Now let's talk about strong consistency. In this model, all nodes agree on the same data before a write is confirmed. It ensures immediate accuracy but comes at the cost of higher latency and reduced availability during network partitions. Think of strong consistency like a group vote. Everyone must agree before the decision is final. So, how do these models compare? Eventual consistency, faster writes, lower latency, ideal for systems like DNS, caching, and social media feeds. Strong consistency guarantees data accuracy at all times, perfect for financial transactions, inventory systems, and critical databases. The choice between eventual and strong consistency isn't about better or worse, it's about what fits your system's goals. Here's how tech giants apply these models. Eventual consistency, Amazon DynamoDB uses it for high-speed, scalable applications. Strong consistency, Google Spanner employs it for globally consistent transactions. These examples highlight how consistency models are tailored to fit specific use cases. Here's how to decide which model to use. 1. Prioritize eventual consistency for scalability and performance-critical systems where temporary inconsistencies are acceptable. 2. Choose strong consistency for applications where data accuracy is paramount, such as banking or medical records. 3. Consider hybrid approaches like tunable consistency to balance trade-offs dynamically. Consistency isn't one size fits all, it's a strategic choice that shapes your system's success. To recap, 1. Eventual consistency offers speed and scalability, but tolerates temporary inconsistencies. 2. Strong consistency guarantees accuracy, but may sacrifice performance and availability. 3. Understanding your system's requirements is key to making the right choice. In our next video, we'll explore CAP theorem in depth, a fundamental concept that ties everything together. Don't miss it. If you're ready to master distributed systems and build resilient, scalable architectures, hit subscribe, turn on notifications, and join me for the next episode. Because in system design, the right consistency model can make all the difference. Subscribe to Hustler Coder Eventual versus Strong Consistency Explained, new videos every week.